In a car race, car A beats car B by 45, car B beats car C by 50, and car A beats car C by 90 kilometers. The distance over which the race has been conducted is how much? You have been given four options. Now, um, as is usual in a straight track race problem, primarily what we need here is direct proportionality, usually between distance and speed. Now this is the way you want to think about this problem. You have some total distance. It is said that A beats B by 45 kilometers. This is A's lead over B at the moment that A has just finished. B beats C by 50 kilometers happens later when B has just finished. I'll call it B dash and C dash. But it's also given that A beats C by 90, which is again the first and the third are two stats that happen at the same instant. That is the instant at which A finishes. So then C is 90 behind A, which also means it is 45 behind B. This is how you want to look at this. B is 45 ahead of C at the moment when B is 45 behind the finish line. Now, what's happening here is by the time B went from here to here, B gained 45 on C. By the time B went from here to here, B gained another 5 on C, so that the total gain is 50. We are getting this 5 from this 50. So B gained 45 on C by the time A finished, and then B gained a further 5 on C. Clearly these gains are in the ratio 9:1, which means that the times spent are also in the ratio 9:1, which means that the distance, because constant speeds for each person, the distance traveled by B in this first portion and second portion are also in the ratio 9:1. This means that out of this 9:1, the one part corresponds to the 45 which is given here, the gap between A and B when A finishes. If that is the case, 9 parts is how much? It's 45 into 9, but I don't need to find that. We need the length of the full racetrack, which is 9 parts plus 1 part, 10 parts. If one part is 45, then 10 parts is 450. 450 should be your final answer. From the interior point of an equilateral triangle, perpendiculars are drawn on all three sides. The sum of the lengths of the perpendiculars is S. Then the area of the triangle is how much? Four options are given. Most importantly, cannot be determined is not one of the options. Now, what the intent and what you would do in a rigorous solution if this question came about in school is you will have to demonstrate that irrespective where you take the internal point, you will get the same answer and you'll have to derive that answer. We don't have to do that here in a competitive exam. The absence of this option tells me that irrespective of which point you take, the expression is going to be the same. So take the most convenient point that you can take. It's basically invariant of the actual position of the point inside the equilateral triangle, and so that most convenient point has to be the centroid, which is also the circumcenter and the incenter and the orthocenter as far as a equilateral triangle is concerned. So then the altitude here, we want to take the sum of the altitudes. We have one here, one here, and one here. We know that these three are going to be equal. And we also know that this part is half of this part, right? 1:2 ratio, because centroid divides medians in 2:1 ratio. So then that means if I take this as x and this is x and this is x, then the sum of the lengths of the perpendiculars 3x is s. Now notice that this 3x is the same as the altitude slash median. So essentially the question boils down to, you have an equilateral triangle. If the median is s, then the area is how much? Now median or altitude, if the altitude is s, the area is how much? We know that this is s. Using some basic trigonometry you can find this, because this side into sine 60 is going to be this altitude. So side into root 3 by 2 is s, which means side is s into 2 by root 3. Now that is the same as this side, because equilateral. So this is also s into 2 by root 3. Now you have the base and the height. The area is half into base into height. Cancel the 2's and you have s square by root 3. S square by root 3 is your answer. In a group of 10 students, the mean of the lowest 9 scores is 42, while the mean of the highest 9 scores is 47. For the entire group of 10 students, the maximum possible mean exceeds the minimum possible mean by how much? The options are 5, 3, 4 and 6. So essentially they're asking find the range of possible values for mean, highest minus lowest. What do we need here? We need change in sum is change in average into number of terms. Not absolutely necessary, but it will make our job easier. This comes from sum is equal to average into number of terms, and then change in sum is change in average into number of terms. So basically we have a group of 10 people, and we have the lowest 9 and the highest 9. So basically we are replacing the first person with the 10th person when you're going from here to here. We are replacing the lowest person with the highest person. That replacement causes the average, give me a second, I'm going to move this down. It causes the average to increase by 5. 42 becomes 47, so that's plus 5, and there you had 9 people. This set is 9 people, one guy is replaced, instead another guy is taken, so that's still 9 people. So n is 9, which means the sum increases by 45, which means that the topper scored 45 marks more than the lowest performer. That's what this means. So we have that. Now we have to look at the range for the mean. Understand that the middle 8 values cannot be found out. The middle 8 values cannot be found out, but there are reasonable constraints on those middle 8 values, because this has to be greater than or equal to, can be equal to as well. This person's score has to be not less than that of these people, all the 9 people below, and this person's score has to be less than or equal to what these people have scored. So those constraints are there. Now with those constraints, what is the lowest sum that the 10 numbers can have? Lowest sum will correspond to the minimum mean, and what you will see is that because the average of the 9 highest scores is 47, the best case I can have is put a 47 and make all 8 of these numbers 47. 1, 2, 3, 4, 5, 6, 7, 8. Let all 9 of them be equal. Let all of them be 47. Their average is 47, and obviously the lowest guy is 45 less than 47, so that's a 2. We are not going to bother calculating the sum. I'll tell you what we'll do, but that's the lowest sum you can have. Anything else, if you put anything other than 47 here, this sum will remain constant, but this number will rise, right? If you put, say for example, 48 here, this sum is still going to be 47 into 9, but this is going to be 3 instead. So that's going to raise the sum and it's going to raise the average. We don't want that. This is the extreme case, the minimum mean. Similarly, the maximum is when you put maximum numbers here and here. This is anyway going to be 42 into 9. If you want to maximize the sum, you want to maximize this number. And the way to do that is to put a 42 here and 42 for all those 8 numbers in between. 1, 2, 3, 4, 5, 6, 7, 8. And then put 45 more than 42, 87 here. Now this was just for illustration. You don't need to write these things down. You just need to understand that the extremes happen when the 9 are equal and the 9 are equal. That's all you need to understand. Now as far as this average is concerned, it is actually plus 45 if you compare with a case where all were 42. Start by thinking, what if all were 42? Then the average would have been 42. But then we replace the last number and increase the sum by 45, which means the average will increase by 4.5. So essentially plus 45 is equal to what is the change in average into 10 people. 10 people all having 42 would give you an average of 42, but when one guy is raised by 45, one of those observations increased by 45, the sum increased by 45 and the average increases by 4.5. So then this extreme case is 4.5 more than 42, so that's going to be 46.5. Similarly, you look at the other side. If they were all 47, the average would have been 47, but this caused the sum to reduce by 45, and so the average is going to drop by 4.5. So it's 4.5 less than 47, which is 42.5. These are the extreme values possible for the means. The difference is 4. The number of pairs of integers x, y satisfying x greater than or equal to y greater than or equal to minus 20 and 2x plus 5y is equal to 99 is. What are the concepts we need here? We need integral solutions to a linear equation in 2 variables. There is a technique to generate integral solutions after you find one of the integral solutions. 2 is you need some basic modular arithmetic, but it's not very complicated here. You can even just do it with odd even parity because one of the coefficients is 2. I'll explain. And then you have the x greater than or equal to y constraint, which is a small twist on what I normally see on this kind of a question, and then counting that the total number of solutions without listing all of them out is usually some basic AP stuff. Number of terms in an arithmetic progression. So what do we do here? We have 2x plus 5y is equal to 99. We need both the variables to be greater than or equal to 20. We also need x to be greater than or equal to y. Now usually when you have something like this, you have a finite number of solutions. At one end you have a solution where x is very large and y is very small, and the other end you have a solution where x is small and y is large. Now let's start at the end where y is small because we want x greater than or equal to y. The other end probably will not satisfy this condition. Now even though I said modular arithmetic because of this 2, it's actually just as simple as looking at the parity. 2x is always even, 99 is always odd, so we need this expression 5y to be odd as well. 5y will be odd when y is odd. Whenever y is odd, you're gonna get a value of x which is an integer. That's what it boils down to. So I want to start with the smallest possible value of y which satisfies the inequation and which is odd. So I'm going to start at y is equal to minus 19. So 2x minus 95 is equal to 99. 2x is 194, x is 97. So 97 comma 19, I'm going to write that a little neater. 97 comma minus 19 is one of the extreme solutions of this. Now how do you generate other solutions? You take the coefficients, you swap them, and you increase. You can decrease this by 5 and increase this by 2. Take the coefficients, swap them, give 2 to y and 5 to x, and you increase one and you decrease the other. Because you started at y at a very low value, you want to increase y and you want to decrease x. So then the next integral solution is minus 1792. Then you will have 87 minus 15, and this will go on until you reach a point where x will become smaller than y. You have to stop counting just before that point. I don't want to list every case here. The way to do this more efficiently is to say the difference between 97 and minus 19 at this point is how much? 116. At this point x is 116 greater than y. What about the next one? 92 plus 17, 109. Notice that the excess that x has over y has dropped by 7, which is understandable because x reduced by 5 and y increased by 2, so it's gonna reduce by 7. How many more times can it reduce? I should just put an arrow on one side. How many more times can it reduce by 7 and still remain positive? Then you'll see that 16 into 7 is 112, and this is actually 16 into 7 plus 4. This is 15 into 7 plus 4, and you can keep going down until you get to 0 into 7 plus 4. You'll get to a point where x minus y has dropped down to 4, and this is the last thing you should count. We don't need to find the corresponding x and y values, although we could do it, but we are interested in the number of solutions. 16 into 7 plus 4, 15 into 7 plus 4, all the way down till 0 into 7 plus 4, clearly 17 terms. 17 is your answer. Now if you're interested in the value of x and y at that point, you have to reduce 97 by 5 16 times. That is, reduce 97 by 80, you'll be left with 17. You have to increase minus 19 by 2 16 times, so that's minus 19 plus 32 is going to be plus 13. Notice that this still has x greater than or equal to y. If you try to take the next one, you will get 12, 15, which does not work. So your solutions are between 97 comma minus 19 all the way down till 17 comma 13, and the number of solutions is 17 terms. You don't want to list all of them. You want to find a pattern where you can apply an AP formula for number of terms in an AP. So here, if you wanted, you could have said 116 minus 4 by 7 plus 1. Last term minus first term by common difference plus 1. You would have gotten the same 17 terms. The value of log of a by b to the base a plus log of b by a to the base b for 1 less than a less than or equal to b cannot be equal to which of the following options? Now, one thing I'll say at the start is usually there is a range of values possible, and that range is usually continuous, which means that the one option out of the 4 that falls outside the range is either the lowest or the highest. Now, if you absolutely do not know how to solve this, just mark one of these two, mark for review and move on. You have 50% chance of getting it right. Okay, now let's talk about solving it. What all do we need? We need a bunch of log identities, one of them being log of a number to itself as the base is 1. We need that. We need log of a by b can be written as log of a minus log of b. We need log of a to the base b is log a by log b. We also need something from inequalities, the AMGM inequality. I believe that's all we have here. How do we put these concepts together? Now, you take the original expression and you apply this identity. It becomes log a to the base a minus log b to the base a. That's the first term. Second term becomes log b to the base b minus log a to the base b. Using this one, you can say log a to the base a is 1, log b to the base b is 1. Add those two up, you have 2. I should just move this a little bit because I want to mark the answer in the end. Yeah, is equal to 2 minus of log b to the base a plus log a to the base b. 2 is this and this, and then 2 negative terms. Take the minus outside, put it inside a bracket. Now you have log b to the base a and log a to the base b. The thing about these two is that they are reciprocals. Log b to the base a, wait, we already wrote log a to the base b is log a by log b. We also have log b to the base a is log b by log a. Clearly they are reciprocals. So I'm simply going to call them x and 1 by x. Now here's the important part. We know that x plus 1 by x, because of the AMGM inequality, is either going to be greater than or equal to 2 or going to be less than or equal to minus 2. Now using the options you can figure out that it has to be this, and then you can find the answer. But they have constructed this question very carefully in such a way that what is x? X is log of b to the base a. We have a base which is greater than 1 and an argument which is greater than or equal to the base. You will see that if b is equal to a, you will end up with log of a to the base a, which is 1 positive value, or you'll end up with a value greater than a, and then your logarithm output will be greater than 1. It's gonna be greater than or equal to 1. It's positive. So that was the condition. For positive x is greater than or equal to 2. For negative x it is less than or equal to minus 2. This is not what is happening. This is what is happening. Your log b to the base a is going to be greater than or equal to 1, and you will end up with 2 minus a quantity which is greater than or equal to 2. This is not standard notation, but you will understand what I'm writing here. 2 minus a quantity greater than or equal to 2, which will leave you with a quantity less than or equal to 0. Anything which is 0 or less is viable. 0 or less is viable, meaning 1 is the thing that is not possible. The final answer is option B. Let the mth and nth terms of a geometric progression be 3 by 4 and 12 respectively, where m is less than n. If the common ratio of the progression is an integer r, then the smallest possible value of r plus n minus m is what? What all do we need here? We need to know the basics of geometric progression, that each number is obtained by multiplying the common ratio r to the previous number in that sequence. We need to know the expression for the nth term of a GP. Then we have to minimize an expression based on integer constraints. So we'll need to prime factorize a ratio obtained from the given numbers as well. Let's see how it goes. We have the mth term of the AP, which is AM, is A into R raised to M minus 1, and that is 3 by 4. We have the nth term, which is A into R raised to N minus 1 is equal to 12. If you divide equation 2 by equation 1, you will get A's will cancel. You will subtract the powers for the same base R, and you will get R raised to N minus M is equal to 12 divided by 3 by 4. 12 into 4 by 3, 16. So R raised to N minus M is 16, which by itself would not lead to anything resembling a resolution, but we have the constraint that R is an integer, which now leads us to a finite number of possibilities, and we have to minimize R plus N minus M. Essentially, we have to minimize the base plus the exponent. The instruction is minimize base plus exponent, and there are only a few possibilities for the base because R is an integer. So that depends on the prime factorization of 16. We can do 16 raised to 1. The sum is 17. I don't like that. It's way higher than all of the options. You will immediately notice that you can do 4 raised to 2 or 2 raised to 4 as well to get to the 16. Both of these give you base plus exponent is 6, and you will see that 6 is present in the options, but it is the biggest one there, and there are other ones including negative ones. Now even if you don't think about it right off the bat, you should think about it at least when you see the options that you could have a negative base. At least when you see this, it should strike you. And so the other possibilities are minus 2 raised to 4, where the sum is plus 2, and minus 4 raised to 2, where the sum of the base and the exponent is minus 2. So you see some of the other options also turning up. But that's it. This is an exhaustive list of everything that you can do, and the lowest is minus 2. This is not possible. Minus 2 is the answer. If x and y are positive real numbers satisfying x plus y is equal to 1 or 2, then the minimum possible value of 2601 into 1 plus 1 by x into 1 plus 1 by y is how much? Now, if you're an alert test taker, you will notice a few things which are very crucial for a efficient non-rigorous solution. We will discuss a rigorous solution afterwards, just in case somebody is interested in it, but I don't want people doing that in the examination. Anyway, first thing to notice is 102 is double of 51. 2601 is the square of 51. And then you have 2601 into 1 plus 1 by x into 1 plus 1 by y. The question is a theta question, which means the output that you have to input, that you have to submit, the final answer that you have to submit is either an integer or a terminating decimal, because they've also not given instructions on how to round your answer. These are all things that are not explicitly said, but you have to notice. So integer meaning something like a 27, terminating decimal meaning something like a 2.5, but is most probably going to be an integer. The very purpose of doing something like this is to convert your fraction into an integer. That's what they always do, but we can't be sure of that. But anyways, yeah, it has to be some sort of either of these categories. All of this will play into how we do hacks, basically non-rigorous solutions. Now, one thing we know about these minimum possible values is when you have a constant sum like this, the extreme values of your final expression either happen, I mean the two extreme values, maybe the maximum value and the minimum value, one of them will happen when they're both equal, one of them will happen when they're most unequal, 0 and 102. So these are the first two things that you should try out. The answer is going to be at one of these points usually, if you're willing to take some risk. But you'll also notice that you can't do this because of two reasons. One is they say positive, they don't say non-negative. The other is you have x and y in the denominator, so you cannot put either x or y as 0. So it's most probably going to be this, and if you plug this in, you will realize that whatever is in the denominator will nicely be cancelled by what is in the 51 square in the numerator, and this will give you the answer. This is one way of looking at it. If you're not confident enough to do this, another way of thinking about it is 2601. Let's look at the prime factorization of 2601. This is where the integer terminating thing comes into play as well. 51 square means it's 17 square into 3 square. Now you want to split up 102 into two numbers x and y, which add up to 102 obviously, such that what is this expression? This expression is a constant number into x plus 1 by x into y plus 1 by y. We want the y and x to be taken in such a way that you won't get these non-terminating decimal situations. So for example 1 by 7, that's going to be 0.142857 recurring. Now if something with a 7 in the denominator is your answer, they should have given us instructions on how to round your answer to how many digits. They've not done that. So these are all things you could notice. Now that means you have x plus y is 102, but you have to take them in such a way that whatever they are can be cancelled by the 2601 in the numerator. And you will see that there is only one way of doing this. This numerator contains two 17s and two 3s, and the only way of doing that is to take 51. Anything else that you can put in the denominator will either be cancelled by 2601 or add up to 102, but not both, right? So this pretty much, they're making it easy by giving you numbers like this. They're actually making it easy for somebody who thinks of a non-regular solution. You can be sure of the fact that you have to take x is equal to y is equal to 51. And if you do that, then the expression becomes 51 square into 52 by 51 into 52 by 51. So the answer is basically 52 squared, which is 2704. So let's also talk about the rigorous approach. All you gotta do is take this and make y is equal to 102 minus x, and so the expression becomes 2601 into 1 plus 1 by x into 1 plus 1 by 102 minus x, and this expression has to be minimized. 2601 is a constant, this has to be minimized. Let's look at what it becomes. It becomes x plus 1 by x into 103 minus x by 102 minus x. Now I'm going to negate both of these, both the numerator and the denominator. It will not change the value of this expression. So it becomes x plus 1 by x into x minus 103 by x minus 102, which becomes x square minus 102x minus 103 by x square minus 102x. This becomes, you distribute it. Where do you distribute? This by denominator minus this by denominator. So when you do that, you will get 1 minus 103 by x square minus 102x. Now what do we need to do? We need to minimize this, which means we need to maximize the thing that is being subtracted from the constant value. To maximize this, Notice that this has a constant in the numerator and an expression in the denominator. To maximize this, you have to minimize the denominator. Now this we know from quadratic, the quadratic equations chapter, that this parabola is going to look like this. Roots at 0 and 102 is going to go down and go back up. Okay, that was bad. It's going to go down and going to go back up, and because it's symmetric, you will have 51 as the x value where the expression is minimized. Or you can go with the formula, the turning point x coordinate is minus b by 2a, y coordinate is also given as minus d by 4a. We don't need this, just mentioning. We have this formula. X is minus b by 2a, from which you can get the x value is 51. X equal to 51 is the value where we minimize the expression. You don't need to do anything more here, just find the 51 and then directly substitute it back into the original expression, and the rest is the same as what we already discussed. For the same principal amount, the compound interest for 2 years at 5% per annum exceeds the simple interest for 3 years at 3% per annum by 1125. Then the principal amount is how much? We need basics of simple interest and compound interest here. That is all we need. If you take the principal as 100x, okay, one more thing I'll mention. If the interests differ by 1125, the amounts also differ by 1125, because we are talking about the same principle. I say this because there is a direct expression for amount in compound interest, and there is no direct expression for the amount of interest. I mean the compound interest for a certain number of years. So the amount under CI is 100x multiplied by 1.05, that's 5% compounded for 2 years raised to 2. You're going to get this as 110.25x. The amount under SI is simply going to be 3% for 3 years is 9%, giving you 109x. The difference is 1.25x. They are saying that this difference is 1125. 125 into 9 is 1125, so 900. X is 900. That means your principal is 100 times 900. 90,000 is your final answer. Let C be a circle of radius 5 meters having a center at O. PQ is a chord of C that passes through A and B. A is exactly 4 meters north of O and B is located exactly 3 meters east of O. We have drawn these things. Then the length of PQ in meters is nearest to which of these numbers? We have a 4 and a 3. We know that this is 5. What is PQ though? That's the question. What all do we need to solve this? Obviously we will need the Pythagoras theorem. We need the area formula of a triangle. We need a certain chord property of a circle. Okay, let's see. So we know that we have a 90 here. We know that AB is 5. 5 will be the value of root of 4 square plus 3 square. So AB is 5. Pythagoras, we're going to use it once more. Area is equal to half BH. So basically what I'm talking about here is you can find the distance, perpendicular distance between the chord and the center, because let's call this D. You can write the area of the triangle AOB using this formula in two different ways. You can take OB as the base, in which case it's half BH, so it's half into 3 into 4. But what if you take AB as the base? It's half into 5 into OD. You can use this to find OD. Half will cancel. OD is 3 into 4 by 5, 12 by 5, 2.4. We now have the perpendicular distance between the chord and the center of the circle. Now if I were to join this line, notice that ODQ is a right angle triangle. Because OD is the perpendicular. Now we can apply Pythagoras again and find DQ, because OQ square is equal to OD square plus DQ square. OQ is a radius, so it's 5. OD has been found to be 2.4 plus DQ square. So DQ is root of 5 square minus 2.4 square. This is going to be root of 19.24, which is approximately slightly less than 4.5. You will see that, you know that 4.5 square will be 20.25. So slightly less than 4.5, maybe 4.3, 4.4. It doesn't matter because the options are pretty close. And the last part is the fact that the perpendicular bisects the chord. The chord property here would be that the perpendicular OD to the chord PQ bisects the chord, so PD is equal to DQ. We found DQ to be 4.4. Using the chord property, we can say that PQ is going to be double of that. It's going to be 8.8 approx. For real x, the maximum possible value of x by root of 1 plus x raised to 4 is which of these options? Now the easy thing to do here is, if you want to maximize this, then you want to minimize its reciprocal. So root of 1 plus x raised to 4 by x. Also notice that all the options are positive. So it's this expression is going to be positive for sure. This is also going to be positive. Anyway, root of 1 plus x raised to 4 by x. You can bring this x into the root and it will become root of 1 plus x raised to 4 by x square. Distribute the fraction. It's going to be root of 1 by x square plus x square. Now you have two terms whose product is 1. So it has a fixed GM of 1, which means its AM, arithmetic mean, has to be at least 1 based on the AM GM inequality. We're talking only about magnitudes here. Now we know this as a result. We know that this expression, something plus its reciprocal, its magnitude should be greater than or equal to 2, which means it's either greater than or equal to 2 or less than or equal to minus 2. That's not really a concern here though. We know it's positive. That's one way of looking at it. The other way is to say, because we have an even power, we know that x square has to be positive in this case. I wouldn't even say non-negative, because you have an x square in the denominator, so x cannot be 0 anyways. So x square is going to be positive. So then this expression has a minimum value of 2. The expression inside the root has a minimum value of 2, which means the full expression has a minimum value of root 2. That means the maximum value of this is going to be its reciprocal, 1 by root 2. Anil buys 12 toys and labels each with the same selling price. He sells 8 toys initially at 20% discount on the label price. Then he sells the remaining 4 toys at an additional 25% discount on the discounted price. Thus he gets a total of rupees 2,112 and makes a 10% profit. With no discounts, his percentage of profit would have been which of these numbers? So what all is required here? We have to do discounts, also successive discounts. What are the concepts involved? Which is essentially percentage stacking, and then we have the basic definition level stuff of profit and loss. You should know the basic formula for profit percent, discount percent, and stuff like that. That would give you a rigorous basic solution, which I wouldn't call efficient. I'll give you the most efficient solution here. This involves some additional concepts which are optional. You don't need them to solve this, but it's good to have them. Now understand that weighted average comes into the picture because your average price at which you're selling depends on weighting these discounts with the corresponding quantities. So weighted average is coming into the picture. We are going to use invariance because they're giving you fractional quantities and asking for an effective fractional quantity. You won't require this number. That's the beauty of this. You can use this number and do all sorts of unnecessary calculations, but you can solve this without using it as well. So let's see what's the most efficient way of doing this. I'm going to invoke invariance and say, I'm going to chuck the 2 at 1 2. I'm going to invoke invariance and say that the undiscounted price is 100. Now after the one discount, reduce it by 20%, it becomes 80. Reduce it by a further 25%, 1/4, and it's gonna become 60. Now weighted average does not depend on the actual quantities but only on the ratio of the quantities. So instead of saying 12 toys and splitting them as 8 and 4, I'm gonna make it even easier for me and I'm gonna simply take it as 2 and 1. So he's selling 2 of them at 80 rupees and 1 of them at 60 rupees for a total SP. Okay, let's call this the MP, the undiscounted price. This is SP1 and SP2. Total SP of 220 rupees for 3 toys. This gives him a 10% profit. So if you want CP, it is 220 divided by 1 plus 10%, and that's gonna be 200 rupees. Now instead, undiscounted pricing would have been 100 into 3, 300. Without discount, the SP would have been 300, the CP is 200, and so the profit percent is 300 by 200 minus 1, 50%. If x and y are non-negative integers such that x plus 9 is z, y plus 1 is z, and x plus y is less than z plus 5, then the maximum possible value of 2x plus y is how much? Now, this is one of the easier questions in the paper. All it requires is linear inequalities. Just the one concept, make a few substitutions and get the solution. So we'll put everything in terms of z. X is z minus 9 from here. Y is z minus 1 from here. And you plug those into the given inequation. Z minus 9 plus z minus 1 is less than z plus 5. Cut one z. Z less than 5 plus 9 plus 1. Z less than 15. Maximum possible value of z should therefore be 14. Given that x and y are integers and z differs from x and y by integral values, So for x and y to be integers, z should also be an integer. So if it's less than 15, the best thing you can do, the highest value is 14. Now if you put z is equal to 14, you will get x is equal to 5, y is equal to 13, and then 2x plus 5, 2x plus y is going to be 2 into 5 plus 13, 23. Students in a college have to choose at least 2 subjects from chemistry, maths and physics. The number of students choosing all 3 subjects is 18. Choosing maths as one of their subjects is 23, and choosing physics as one of their subjects is 25. The smallest possible number of students who could choose chemistry as one of their subjects is how much? Now, the question says you have to take at least 2, so the people who take only one of those 3 subjects, they do not exist. That's why we have a 0. You can't take 0 subjects. You can't choose to skip all of them, so nobody there either. So that's why we have those zeros. It is given that there are 18 people in the triple intersection. I've noted it. What else is given? Choosing maths as one of their subjects. One of 2 subjects or all 3 subjects is what we need to understand from this. Is 23, which means you have an 18 here. You should have a 5 for these 2 combined. So that would make it a total of 23. Similarly, we have physics, 25. 18 here, you need 7 here. Now what I'm going to do is I'm going to simply put an x here. At which point this would become 5 minus x. Notice that these two will add up to 5 plus 18, 23. Similarly, you will have a 7 minus x here. Now the question is, smallest possible number of students who could choose chemistry. That expression would be 18 plus 7 minus x plus 5 minus x, which is 18, 30 minus 2x. 30 minus 2x is what I need to minimize, which means I need to maximize x. Now what's the maximum value I can give for x? You have a 5 minus x here, you have a 7 minus x here, you have an x here. Remember that every segment in a Venn diagram has to be a non-negative integer when we are talking about number of people. So then you will see that the maximum you can throw here is a 5. That will correspond to a 0 here. Anything greater than 5 will give you a negative value here, and that's going to be a problem. So 5, 0, 2. Now either you can just add this up and see that you have 18 plus 2 plus 0 plus 0, answer is 20. Or you can simply just, you know what, I'll just leave that there. Yeah. Or you can simply say that what I need to substitute here as a maximum value of x is 5. 30 minus 2 into 5 is going to be 20. Let f of x is equal to x square plus ax plus b, and g of x is f of x plus 1 minus f of x minus 1. If f of x is always greater than or equal to 0 and g of 20 is 72, then what is the smallest possible value of b? Now what all concepts are required here? We need basic evaluation of a function basics. You have a function g which is defined in terms of a function f, so we need to get an explicit definition of g of x directly in terms of an expression in x. Substitute the input output pair 20, 72 and get the value of a parameter. We have a quadratic expression which is always greater than or equal to 0. At that point we'll need to bring in either the discriminant concept or you can just go completion of squares. Now the discriminant expression itself is derived by using completion of squares, so just go straight to the source is what I would say. It's more efficient. Let's see. So we have f of x is equal to x square plus ax plus b. This means f of x plus 1 is going to be x plus 1 whole square, which I'm going to directly expand, x plus 1 whole square plus a into x plus 1 plus b. F of x minus 1 similarly is going to be x minus 1 the whole square plus a into x minus 1 plus b. What happens if you subtract these? That's what g of x is, right? G of x is f of x plus 1 minus f of x minus 1. So what's g of x? G of x is going to be x square minus x square, cancel. The only things that are not cancelled are where you have different values. That's it. So that gives me 4x plus 2a. I have a definition of gx directly in terms of x. A is a arbitrary constant. G of x is equal to 4x plus 2a. Now we bring in the point, the input output pair. G20 should be 4 into 20 plus 2a, but it's given as 72. Solving it, you will get 2a is 72 minus 80. 2a is minus 8, a is minus 4. If you plug this back into the original function f of x, you will see that f of x is x square plus 4x plus b, which should be always non-negative. What is the smallest possible value of b? That's the question. Now for it to be always non-negative, it has to be a perfect square or something that's more than a perfect square. And using completion of squares, we know that we should have x square plus 4x plus 4. This is a perfect square. What does it look like? It would look like this, because it's x plus 2 the whole square. Now you need at least this much, or you could have something that is directly above it. So as an example, x square plus 4x plus 5. This would also work. What won't work is when it is something directly below it. Like reduce it by a constant, something like x square plus 4x plus 3. This doesn't work. This works, and obviously the perfect square also works. But they're asking for the smallest possible value of b. For that case, you have to use the perfect square itself. This is the smallest one. So then the value of b that I should use should be 4. That's the minimum value that will ensure that fx is always non-negative. The answer is 4. The distance from B to C is thrice that from A to B. 2 trains travel from A to C via B. Thrice from A to B. Yeah. The speed of train 2 is double that of train 1 while traveling from A to B, and their speeds are interchanged while traveling from B to C. The ratio of the time taken by train 1 to that taken by train 2 in traveling from A to C is how much? Now people would tag this as a time and distance question, but there's not much time and distance happening here, much concept wise. It's mostly just direct and inverse proportionality. Obviously you should know the basic proportionalities there. Distance is speed into time means that distance is proportional to time when speed is constant. Distance is proportional to speed when time is constant. Speed is inversely proportional to time when distance is constant. Now we'll need this and this, I believe. Yeah. So it's proportionality primarily. We'll also make use of invariance. Now the distances are in the ratio 1:3. You can take it as D and 3D if you want, doesn't matter. 1:3. Trains travel from A to C via B. Speed of train 2 is double that of train 1. Now if the speed is double, the time will be half. I'm gonna write train 2. Wait, we want 1:2. So I'll write train 1 above, train 2 below. Speed of train 2 is double that of train 1 while traveling from A to B. So the time taken will be half. Let that time be 1 hour. So the time taken by train 1 will be 2 hours. Now, after this, their speeds are interchanged. I'm going to ignore this for a bit and then come back to it. Now, if the speeds had not been interchanged, what would happen in the second leg of the journey? Because the distance is thrice, the time taken would also have been thrice. That is distance proportional to time. And for the other guy also, if he took 1 hour in the first leg, he will take 3 hours in the second leg. That is all there is to it. Now, because there is an interchanging of the speeds, the train 1 is going to take 3 hours, while the train 2 is going to take 6 hours. And so train 1 takes a total of 5 hours, train 2 takes a total of 7 hours. The answer is 5:7. The sum of perimeters of an equilateral triangle and a rectangle is 90 centimeters. The area T of the triangle and the area R of the rectangle, both in square centimeter, satisfy the relationship R is equal to T square. If the sides of the rectangle are in the ratio 1:3, then the length in centimeter of the longer side of the rectangle is how much? Now this is one of the more time consuming questions in this paper. It's a little bit to do, but it's not too complicated. What are the things we need? We need the formula for perimeter and area of both equilateral triangle and the rectangle. We have an expression here that can be used to equate. We have a 90. My recommendation is to only bring that 90 in at a later stage, after we can find the relationship between the side of the triangle and the sides of the rectangle, which can be found from this. Let's see how it goes. We have a triangle with a side S. That's my variable. Its area is gonna be, area of the triangle is gonna be √3/4 S square. That's the formula for area of equilateral triangle. Now, the square of this value is 3/16 S⁴. What about the rectangle? Rectangle is sides in the ratio 1:3. I am choosing to call the shorter side as the breadth, and the longer side, the length, is gonna be 3 times the breadth. So then the dimensions are B and 3B, and so the area of the rectangle is gonna be 3B square. They are saying the area of the rectangle is equal to the square of the area of the triangle. So 3S⁴/16 is equal to 3B square. I'm going to write it separately. 3/16 S⁴ is equal to 3B square. Cut the 3's, take root. You have B is equal to S²/4. So I'm going to take the dimensions as S²/4 is the breadth and the length is 3 times of that, 3S²/4. These are the dimensions of the rectangle using the same variable that I defined for the triangle. What I did was I substituted B in terms of S. So I don't need B anymore. I have modeled everything in terms of one variable. This is important. So 1/4 S square and 3/4 S square means that the semi perimeter would be 4/4 A square or S square. The perimeter of the rectangle would therefore be double of that, 2S square. 2 into L plus B basically. 2 times b plus L would give you 2s square as the perimeter of the rectangle. What about the perimeter of the triangle? It's simply 3 times the side, 3s. So I have an equation, perimeter plus perimeter is 90. I have brought it to a form where I have only one variable. Now is when you use the 90. You have 2s square plus 3s is 90. Solve this quadratic and you will get the value of s, from which you can find the value of L, and then that would be the answer. You can either do this rigorously, 2s square plus 3s minus 90 is equal to 0. Product is 180, difference is 3. What's that gonna be? 12 into 15? Anyway, 12 into 15, that'll work. Now, when I know that the answer is integer, what I usually do is I'll just prime factorize. I'll keep the constant on the other side. S into 2s plus 3 is equal to 90. You don't have to do this. If you're comfortable with this, it's something you can adopt in certain situations. I'll just prime factorize the 90 and see what works. I need two numbers where one is 3 more than twice the other. You'll see that 6 into 15 fits the bill. S has to be 16. Sorry, S has to be 6. You don't have to do this. You can factorize, no problem. Anyway, S is 6. What we want is L. L is 3s square by 4. It's 3 into 6 square by 4. That's 3 into 9, 27. The number of integers that satisfy the equality x square minus 5x plus 7 raised to x plus 1 is equal to 1 is. What all do we need? We need a little bit of quadratic. We need to know some basic results in exponents. What are the ways in which I can get 1? There are 3 cases. If you have 1 raised to anything, let's just put 1 raised to some power p, that's going to be equal to 1. Case 2, if you have minus 1 raised to any even integer, so I'm going to write 2k, that's going to be equal to 1. We have case 3, anything non-zero raised to 0 is going to be 1. b not equal to 0. Let's look at these cases one by one. Case 1, x square minus 5x plus 7 is equal to 1 gives you x square minus 5x plus 6 equal to 0. That is x minus 2 into x minus 3 equal to 0. X is 2 or 3. We got two values. So in both of these you will get 1 raised to, if x is 2 you will get 1 raised to 3. If x is 3 you will get 1 raised to 4. Both are 1. Two solutions from case 1. Case 2, x square minus 5x plus 7 should be minus 1 and x plus 1 should be an even integer. If these two conditions are simultaneously satisfied, that's case 2. But this gives you x square minus 5x plus 8 equal to 0. This does not have any real solutions. If you take the discriminant, you will see that it is less than 0. Alternately, if you're thinking in terms of completion of square, you will see that x square minus 5x plus 6 1/4 is the perfect square, and there's a little bit more. So you're looking at a curve that's entirely above the x-axis. That's your 1.75. So there's no real solution here. And the last case is something raised to 0. So then you just have to take x plus 1 equal to 0 or x is equal to minus 1. If you want, you can just substitute that here and see that is not going to be 0. But again, even this one is a curve that's entirely above the x-axis. So that's not going to happen. We know it doesn't have a real root. So it's going to be some non-zero value raised to 0. X plus 1 is equal to 0, x equal to 1. That's your third solution. You have 3 solutions. In how many ways can a pair of integers x comma a be chosen such that x square minus 2 mod x plus mod of a minus 2 is equal to 0? There are many ways to do this. You can go for a purely equation based approach, but I will show you a graphical approach. Now for that I'll need a graph transform. Also, because we have a mod function, we need to know the basics of mod function, how to write the cases, 2 cases usually when you have a mod. So you need graph transforms and a basic understanding of the mod function. So I'm going to isolate this part. This is the part that contains x. This is the constant part. I want to plot a graph for x square minus 2 mod x. And the way that I'll choose to do that is to first define a function f of x is x square minus 2x. And then if this is the case, what is f of mod x? F of mod x is going to be mod of x the whole square, which is x square, minus 2 times mod x. So my required graph is f of mod x, where f of x is x square minus 2x. We know how to plot this using basic shifting and scaling, using completion of squares. You can either do that, in which case you will just say a square would be plus 1 and then you do minus 1, and then you can say it is x minus 1 the whole square minus 1, which means you take the y is equal to x square parabola, shifted right by 1 unit, shifted down by 1 unit. That is one way of doing this. Another way to do that would be to simply say x square minus 2x is nothing but x into x minus 2. So you have roots at 0 and 2, and so the lowest point will be at x equal to 1. So it passes through 0 0, it passes through 2 0, and then its lowest point is at x equal to 1. The corresponding y value can be obtained by substituting 1 here and here, and you will get 1 comma minus 1. Now this can be roughly plotted. My y is equal to f of x is going to look like this. You have 0 0, 2 0, and the lowest point 1 minus 1. It's going to look something like this. The original y is equal to x square parabola shifted right by 1 unit and down by 1 unit. That is y is equal to f of x. Now if you have that graph, how do you then plot y is equal to f of mod x? Delete the negative x side and copy paste from the positive x side. So this will disappear, this will remain there, and a copy of that, a mirror image of that, will be created on the other side as well. Now this part in magenta is my x square minus 2 mod x. That's the first part of solving this. Now let's mark these points as well. It is 2 0, it is 1 minus 1, it is 0 0, it is minus 1 minus 1, and this is minus 2 0. Now to this function of x, we have to add mod a minus 2, and then the resultant should be 0. Now understand that mod a minus 2, because it's the output of a mod function, should be non-negative. It should be 0 or positive. So then a solution can only exist here, here. Remember also that x and a are both integers, so the solutions will only exist at these 5 points. Now at the point which is on the x-axis, we want mod a minus 2 to be equal to 0, which will give you a minus 2 also is 0, a is equal to 2. Now this means at this point a is equal to 2, a is equal to 2, a is equal to 2. What about these points below the x-axis? There I want mod of a minus 2 to be plus 1. The output of just the f mod x part is negative. I need a 1 to be added for my final expression to go up to 0. So I need my mod a minus 2 to be equal to 1, which means a minus 2 is minus 1 or plus 1. Transpose the 2 and you have a is equal to plus 1 or plus 3. So at this point, a needs to be either 1 or 3. At this point also, a needs to be either 1 or 3. Now we want how many ordered pairs x comma a? Let's look at what all we have found. We found x equal to minus 2 here, x equal to minus 2, and a is equal to 2. On the origin, x equal to 0, y is equal to 2. Here we have x equal to 2. Sorry, I meant to say xa. We have x equal to 2, a is also equal to 2. 3 solutions from the points of f mod x which are on the x-axis. We have more solutions from the points which are below the x-axis. When x is minus 1, a can be either 1 or 3. 2 more solutions there. Minus 1, 1, minus 1, 3. Here when x is 1, same situation, a is either 1 or 3. X is 1, a1, x1, a3. So you have 3 solutions here, 4 solutions here, for a total of 7 solutions. Two circular tracks T1 and T2 of radii 120 meters respectively touch at a point A. Starting from A at the same time, Ram and Rahim are walking on track T1 and track T2 at speeds 15 and 5 respectively. The number of full rounds that Ram will make before he meets Rahim again for the first time. You have a radius of 100, you have a radius of 20, speed of 15, speed of 5. Now, this looks like a circular track question, but I would argue it's just a proportionality question. There are no specific concepts or results from circular track that need to be applied. It's all about finding ratios and finding an LCM. Now, for them to meet, they should both be back at the starting point, and that means completing an integral number of rounds. So the relevant thing here is to find the ratio of the lap time. You could find the actual lap times. That is how the question setter intends that you waste time. So you don't need to do that. What is relevant here is just the ratio of lap times, not the actual lap times themselves. So we have a time ratio, which is simply a distance ratio by a speed ratio. Now the distances are the circumferences. Circumference is proportional to radius. So then circumference ratio is going to be the same as the radius ratio. It's simply 100 by 20. Speed ratio is directly given to us. It is 15 by 5. So this is 5 by 3. The lap time ratio is 5:3. Ram takes 5 units of time, where Rahim takes 3 units of time. What that 1 unit is, I don't know, and I don't care. What we need to understand is, if he does 3 rounds, he is going to take 15 units of time. If he does 5 rounds, he is also going to take 15 units of time. And this is the first time that they will meet, because 15 is the LCM of 5 and 3. Essentially, the number of rounds ratio is going to be the inverse of the lap time ratio, but make sure you make it co-prime as well. So for example, if you got 6 by 10, don't say 6 rounds. 6 by 10 is simplified to 5 by 3, and then you will say 3 rounds. Ram has done 3 rounds by the time they meet for the first time. Answer is 3. A and B are 2 points on a straight line. Ram runs from A to B while Rahim runs from B to A. After crossing each other, Ram takes 1 more minute to reach B, while Rahim takes 4 more minutes to reach A. If they start at the same time, then the ratio of Ram's speed to Rahim's speed is which of these options? Now this pattern of question has been around long enough that we have derived results for it. Basically, time taken to meet is the geometric mean of the time taken by A after meeting and the time taken by B after meeting, if A and B are the people. That's one formula. The speed of A by speed of B is the inverse root. Like speed ratio is inversely proportional to the root of the time taken after meeting. We have discussed this in the concept videos. If you are interested in the derivation, you should check out the concept video. What we need is just this result. Speed Ram by speed Rahim is simply the square root of the 4 minutes taken by Rahim divided by the 1 more minute taken by Ram. The answer is 2:1. Let C1 and C2 be concentric circles such that the diameter of C1 is 2 cm longer than that of C2. If a chord of C1 has a length of 6 cm and is a tangent to C2, then the diameter of C1 is how much? So concentric circles means they have the same center. They're asking for the diameter of C1, which is the outer circle. C1 is outer because the diameter is longer. What are the concepts we need? We need Pythagoras theorem. We'll save a little bit of time optional if you know some Pythagorean triples, but it's not necessary. You can solve rigorously without it and still get it. That's one. The other thing is a chord property of a circle. That chord property basically is if you have the midpoint of a chord and the center of the circle, and you join them, that's going to be perpendicular to the chord itself. Now the way it's structured is if any two of these things are true, then the third will be true. So you take the midpoint of the chord and join it to the center, that line is going to be perpendicular to the chord. If you take midpoint of the chord and draw a line perpendicular to it, it will pass through the center. If you draw a perpendicular from the center, it will bisect the chord. Any two are true, then the third will also be true. So that's a chord property that we need. So what do we have here? We have a chord of C1 that's of length 6 and it is tangent to the inner circle C2. So that's going to look something like this. Now, okay, one more thing, radius perpendicular to tangent. That means because it's a tangent, it is perpendicular to the radius. So it's essentially a perpendicular drop from the center to the chord of the outer circle. It is a chord of the outer circle while it is a tangent of the inner circle. Anyway, perpendicular drop from the center to the chord of the outer circle. So it's going to be it's going to bisect the chord. So this side is going to be 3 and this side is going to be 3 as well, because the total was given as 6. Now it's given that the diameter is 2 longer than the diameter of the other one, which is the same as saying radius is 1 longer. R1 is 1 longer than R2. So notice that this vertical line is the radius of the inner circle, and notice that this slanting line here is the radius of the outer circle, which is 1 longer. So it's R plus 1. So we have a right angle triangle containing 3 and R plus 1. Now anybody who has done a few questions with Right angle triangles would know that the relevant Pythagorean triple here is 3, 4, 5. It should contain a 3 and the other two sides differ by 1. It is 3, 4, 5. In case you didn't know this, you will have to say 3 square plus r square is equal to r plus 1 square. Solve it rigorously. That's going to waste a little bit of time. You can just directly plug in known Pythagorean triples at least for a couple of seconds. See if they work. It's 3, 4, 5. So we have a 4 here. We have a 5 here. They want the diameter of the outer circle. Radius of the outer circle is 5, so the diameter is 10. John takes twice as much time as Jack to finish a job. Jack and Jim together take 1/3 of the time to finish the job than John takes working alone. Moreover, in order to finish the job, John takes 3 days more than that taken by the 3 of them working together. In how many days will Jim finish the job working alone? So here's another question that could be tagged into an arithmetic chapter, time and work, but then it doesn't go into the specifics of time and work concepts. All you need is a good understanding of proportionality. So what we have here is work is equal to speed into time, which gives us speed is inversely proportional to time for the same work. If you know this and you know how to apply this well, you don't have to write too many equations. You can easily get the answer. So we have John and Jack initially, and then Jim is also brought in. John and Jack. John takes twice as much time. We have the time ratio and the speed ratio. So time ratio is 2:1, then the speed ratio will be 1:2. Jack takes less time, so he's faster. That is the first line. Second line says Jack and Jim together take 1/3 of the time. That means they have thrice the speed as John. So these two numbers together should be 3. John was 1. Corresponding speed for Jack plus Jim should be 3, which means Jim's speed should also be 1. That is the second line. Third line, moreover, in order to finish the job, John takes 3 days more than the time taken by the trio. So if you also bring in trio, I'm going to remove this plus. John is to Jack is to Jim is to trio. What is the speed of the trio? It's 1 plus 2 plus 1. It is going to be 4 in the same ratio. Notice that the trio is 4 times as fast as John. Speed ratio for trio by John is 4:1. The time ratio is going to be 1:4. It is given that John's time is 3 days more than that of the trio. So the 4t is 3 days more than the 1t. Solving this, you'll get t is equal to 1, which means time taken by John is 4 and time that would be taken by the trio if they did it together from start to finish, they would take 1 day. So the time taken by the trio is 1 day, time taken by John is 4 days. They're asking how much time will Jim take to finish the job working alone. Notice that Jim has the same speed as John, so he should also have the same time as John. It should be 4 days. In May, John bought the same amount of rice and the same amount of wheat as he had bought in April, but spent 150 more due to price increase of rice and wheat by 20% and 12% respectively. If John had spent 450 on rice in April, then how much did he spend on wheat in May? So basically you have rice and wheat, the amount spent in April and May. Amount spent by John on rice is 450, and notice that they've said same amount of rice was bought in April as May. The quantity is the same. Same with wheat, the quantity is the same. So if you're buying the same quantity but is 20% costlier, it's gonna cost you 20% more rupees. 20% of 450 is 90. and you spend 540 rupees. Now what is given is total he spent 150 more rupees. That means the increase in the total cost of the wheat that he bought should have been 60. And that 60 was because of this 12%. There is a certain quantity that he bought the same quantity next year. It's going to cost him 12% more, and that 12% is 60 rupees, which means 1% is 5 rupees, and he spent 500 in April. They're asking you what he spent on wheat in May. That's the answer. It should be 12% more than 500, or basically just 60 more than 500. The answer should be 560. Aaron bought some pencils and sharpeners. Spending the same amount of money as Aaron, Aditya bought twice as many pencils and 10 less sharpeners. If the cost of one sharpener is 2 more than the cost of a pencil, then the minimum possible number of pencils bought by Aaron and Aditya together is how much? Now this question it basically boils down to a system of linear equations, or let's just say system of equations, which is not fully resolvable. There'll be more variables in the number of equations you have, but the search space is gonna be extremely limited by the integer condition. The number of pencils bought by the first person, second person, sharpeners by first person, sharpeners by second person, all of these are constrained to non-negative integers. This constraint is going to give you a minimum, and that's the only way to solve this. So here's what you're going to do. Let's say first guy bought m pencils. M is the count. I'm taking P as the cost of a pencil, and then he bought n sharpeners. So the amount of money he spent would be MP plus NS. Second guy bought twice as many pencils and 10 less sharpeners. Now it is given sharpener is 2 more than a pencil. So S is P plus 2. So that's basically all you have. You have these three equations. You have 4 variables. Not fully resolvable, but there will be some minimum that you can find with the integer constraint. So let's substitute this. S is equal to P plus 2. Okay, it's not 3 equations. I have to equate these two. So it's essentially 2 equations. S is equal to P plus 2 is something that I'm going to substitute here. So I'll get MP plus N into P plus 2. We have 2MP plus N minus 10 into P plus 2. And we know that MP plus N into P plus 2 is equal to 2MP plus N minus 10 into P plus 2. Let's expand. We have MP, we have NP, we have 2N, we have 2MP, NP, 2N minus 10P minus 20. You can cut a lot of things here. NP, 2N, NP, 2N, MP is cut out the second MP, and you have MP minus 10P minus 20 equal to 0. So let's write it as MP is equal to 10P minus 20. So that's what we got. We got an equation MP is equal to 10P minus 20. What's the question? Minimize the possible number of pencils bought by Aaron and Aditya together. Number of pencils M plus 2M, 3M. So the requirement is 3M minimum. What is the minimum possible value of 3M? For that we have to first minimize M. Let's look at this equation. Let's make M the subject. It becomes M into 10P minus 20 by P distributed, and you will have wait, this should have been a plus. Yeah, they're both minus. On the other side is a plus. M is equal to 10 plus 20 by P. That's what you will get. M is equal to 10 plus 20 by P, but remember that M has to be an integer. So then and p is positive. We don't necessarily know that p is an integer, but we know that p is positive. So this value is going to be greater than 10 and it has to be an integer. The smallest value you can get is 11. And that happens when you put p is equal to 20. If the price of the pencil is 20 and the price of the sharpener is 22, you will end up with m is equal to 11 and 3m minimum will be 33. 33 is your answer. A sum of money is split among Amal, Sunil and Meeta so that the ratio of the shares of Amal and Sunil are in the ratio 3:2. While the ratio of the shares of Sunil and Meeta is 4:5. If the difference between the largest and the smallest of these three shares is 400, then Sunil's share is how much? Very basic question from ratio proportion. You need to combine two known ratios to get the ratio of three terms. You also need to do some basic direct proportion to go from the given 400 to the required unknown. So what do you have? You need to combine this. What do you do? You can rewrite this 3:2 as 6:4. Now you have 6:4 and 4:5, at which point you can combine it and say 6:4:5. First guy is 6 parts, second guy is 4 parts, third person is 5 parts. What is the given? Difference between the largest and the smallest. That is 2 parts. Given 2 parts is 400. Find Sunil's share. Sunil's share is already 4 parts. 4p. If 2 parts is 400, then 4 parts will be double of that, 800. How many 4-digit numbers, each greater than 1000 and each having all 4 digits distinct, are there with 7 coming before 3? Now this is a permutation combination question. There is a condition 7 before 3, that is basically subgroup in specific order, and the result for that is to look at how many items are there in the subgroup and put that number with the factorial in the denominator. So if you have 4 distinct items, it can be permuted in 4 factorial ways, but out of those 4, there are 2 specific items that I'm interested in putting in such a way that one should be before the other. Then I'll have a 2 factorial. Similarly, if I had A, B, C, D and I told you permute in whatever way you want, but A should be before B and B should be before C, then the number of permutations will be 4 factorial for the 4 distinct items and a 3 factorial in the denominator, because you're specifying an order for this subgroup of 3 items. That's the main concept here. Then we know what always happens when you have something about a 3-digit number, a 4-digit number, etc. 0 is different, because if you select a 0 and put it in the left end, it will no longer be a 4-digit number. These are the things to remember. So because 0 is different, the number of permutations for a selection that contains 0 is going to be different from the number of permutations for a selection that does not contain 0. So then you need to take separate cases for that. So then I'll have a case 1 does not have 0, which means after selecting 3 and 2, step 1, selection. After selecting 3 and 7, I have to select 2 more items from the remaining 8 digits. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I've selected the 7, I've selected the 3, 8 items remain, but I can't choose 0. So there are 7 items left from which to choose, and I need to choose 2 items. So that's 7C2, step 1. Independent of this, you have step 2. That's where the FTC comes in, fundamental theory of counting. Invariably, you will need this in pretty much every permutation question that comes your way. Second step, we have some result that needs to be multiplied with that of the first step according to FTC. Anyways, number of ways of permuting these 4 items. Imagine that you had selected 7 and 3 and 1 and 2 as an example. Normally, if you wanted to permute these 4 items, you would simply say 4 factorial. But because of the subgroup that needs to be in a specific order, you'll put 2 factorial in the denominator as well. That is case 1. This is 7c2 is 21, 4 factorial is 24, half of that is 12, 20 and 12, 240 plus 12, 252, case 1. Then you have a case 2, has 0. How is this different? Let's say I have a selection, I had 7 and 3 already, then I select a 0, then I need to select one item from the remaining 7. So the first step of selecting is actually 7c1. I had 7 3, I selected the 0, now I have to select 1 from the remaining 7. 7c1. Step 2, arrangements per selection. Now if you have something like 7 3 0 1, even without the subgroup specific condition, you cannot permute in 4 factorial ways, because that would also include a permutation that looks like this. I don't want this. So when I am permuting and creating an arrangement, the leftmost dash can be filled with anything other than 0, so it can be filled in 3 ways only. And then one of the 4 items is gone. The remaining 3 items can be filled in any way you want, no constraint. That's going to be 3 into 3 into 2 into 1. Remember that this is without the 7 before 3 condition. Incorporate it and you'll have a 2 factorial in the denominator. So this is going to be 7 into 9, 63. If you add these two things up, you will get 315, and that is your answer.